So I am Sridhar Kanuri. I'm the Chief Technology Officer for Hyaxium. I'll give a brief overview of our organization, the products that we work on, and then the customers we have, and then open up for questions. So Hyaxium was formed in 2014 after Doosan, a Korean conglomerate, acquired UTC Power. UTC Power started in the area of fuel cells by making fuel cells for the Apollo space mission. So the astronauts that went to the moon actually drank the water that came out of these fuel cells that were on that spacecraft. Then they started venturing into fuel cells for further space missions. And all of the US manned space missions till 2010, when the Space Shuttle Orbiter used our fuel cells that were made in Connecticut. Then with the background of that technology, UTC Power ventured into both stationary and transportation fuel cells. In the area of stationary fuel cells, they deployed a 200 kilowatt phosphoric acid fuel cell in 1990. That is shown in the top second picture on the top after the Apollo spacecraft. And then in the bottom below, you see a hydrogen fuel bus. And at the same time, they started working on fuel cells for bus applications. And in 2006, we launched a bunch of buses, a lot of them in California also, for demonstration using our fuel cell. And one of these buses, I lost track of it, but the last I heard, crossed more than 20,000 hours of operation in the field, and was probably the longest running fuel cell bus in the world. And then with the knowledge gained in these two programs, we launched the Pure Cell Model 400 in late 2000s. And that's the product that Hyaxium today still works on. We have improved that product over the course of time, and that's what we work on. In 2014, UTC Power was acquired, or the technologies associated with UTC Power were acquired by Doosan. And post Doosan, we have expanded our production capacity, and we have deployed a lot of our units into the Korean market, and also in California and in Connecticut. So, small introduction to the Doosan Group. As mentioned, it's a Korean conglomerate, and Hyaxium falls under the Doosan Corporation. Under Hyaxium, we have Doosan Hydrogen Innovation, and also our service branch, which is Hyaxium Korea branch. And as part of both these organizations, we look at next generation fuel cell technologies and also provide service to our customers in Korea. Doosan, in the past 1 year, has been researching a lot into the hydrogen market. There is a strong push from the Korean government to get into hydrogen. And at the same time, we are seeing significant interest in the US market also with regards to hydrogen, especially with President Biden passing the Inflation Reduction Act and having significant amount of incentives for fuel cells and hydrogen-related products. There is significant excitement in this area, and Doosan is also restructuring its businesses to be part of the hydrogen value chain, and Hyaxium forms the key entity in that process. So Hyaxium, where are we? As mentioned before, we started with the fuel cell program for the Apollo space missions and the space shuttle. And then in 2014, we transitioned to Doosan Fuel Cell America, and we recently changed our name to Hyaxium. We have 318 employees in Connecticut. We have an installed base of more than 500 megawatts, approximately 57 megawatts in the US and 500 megawatts in Korea. And our production capacity in the US is 66 megawatts per year. And this is planned to be scaled to 85 to 90 megawatts by next year. As an organization, we have strong background in the area of fuel cells, so we have significant patents in the area of fuel processing, cell stack design, systems, and also solid oxide fuel cell. So what are the products we work on? Our core product is called PureCell Model 400. This unit has 3 different versions. The base model operates on natural gas. But we've also upgraded this model to run on liquefied propane gas for certain customers. And also, if the customer has pure hydrogen available, this model can be easily changed to run on hydrogen. So that is the core part of our business, but we are venturing into multiple products going forward. So the second one is a PEM electrolyzer. Polymer electrolyte membrane electrolyzer. This is in development, and we are planning to get to verification testing of this product by the end of this year. It is currently being assembled in our factory, and we are going to continue verification into next year and then deploy 3 of these units into various demonstration projects across Korea and Middle East. And with that data coming in, and in parallel, we are going to upgrade our factory to make approximately 50 megawatts of these starting 2024. The third product that I have on the top is PEM fuel cells. We are going back to our roots of working into putting fuel cells into buses and trucks. Over the course of the past few years, we've seen significant interest in this area. I especially started working in the area of fuel cells on transportation applications. So when I started with UTC Power, I worked on fuel cells for various auto manufacturers that worked with UTC Power, such as BMW, Hyundai, Nissan, Toyota, and a lot of these companies we did transfer a lot of knowledge and work with them to create some prototype products. And now those companies have their own internal programs. In addition to those on the top, we are launching a solid oxide fuel cell product in 2024 also. And we are looking at this being applied for maritime applications also. We recently signed an agreement with Shell to deploy these fuel cell power plants in LNG carriers. And we expect that to be demonstrated late 2024. And the last product that you have is Trigen. This is again an offshoot of the original PureCell Model 400. Simplistically thinking about it, our power plant today produces 440 kilowatts, the PureCell Model 400. If you operate that power plant at 300 kilowatts, then you have that extra 140 kilowatts which you can take out as hydrogen from the unit and use it for fueling cars, trucks, or buses. So this is a Trigen product that we have recently launched into the Korean market. And to put that in perspective, 140 kilowatts worth of hydrogen can fuel roughly 25 to 30 cars a day, fuel cell cars, or approximately 10 or so buses or trucks. And our objective is that this is going to spur the hydrogen economy and create this infrastructure that is lacking today as we transition to hydrogen economy. So now, on the next slide, I'll give a brief description of our product. So, shown on the left-hand side is our core product, the PureCell Model 400. So, at the bottom, you see flexible fuel. So, let's start, assume that natural gas goes into the power plant. As natural gas enters the power plant, the first thing we do is remove sulfur from natural gas. Sulfur is added to natural gas as an odorant, but it's a poison for the catalyst in the reformer section. So we remove that, send the methane and natural gas to the reformer, where it is converted into hydrogen. Hydrogen goes to the fuel cell stacks, where DC power is generated, and at the same time, there is also heat that is generated during the reaction. So we capture both the heat and also the electricity. The DC power is converted to AC power in our electrical system module, and a series of heat exchangers can capture the heat from the cell. The cooling tubes on the cell stacks transfer the heat to a series of heat exchangers, which then exchange that heat with the customers. So if a customer can use all the heat that is available from this unit, they can get close to 90% efficiency. There are very few customers that can get to 90% efficiency, and we have, for example, a casino in Connecticut. They have integrated the heat really well, and they were able to get up to 89.9% efficiency. Our typical customers get anywhere between 70 to 75% combined heat and power efficiency. They use all the electricity that comes out of the unit, which is at 43% efficiency, and then they're able to use some of the heat very effectively and achieve approximately 70 to 75% efficiency. So now, if you take this power plant and if you put a preprocessor in front of it, then we can use this power plant to operate on LPG. And this LPG is a higher hydrocarbon that gets converted to methane type composition or natural gas type composition in the pre-reformer, and then sends it to the power plant. So that is the LPG unit. If you take the front fuel processing section out of the power plant, which we can easily do because this power plant is built on a modular basis, then this power plant can operate on pure hydrogen. When hydrogen becomes widely available, we envision that the customers can easily retrofit our power plants to operate on hydrogen. And with hydrogen, the electrical efficiency goes up to 50%, and the customers can get up to 87% overall combined heat and power efficiency. Moving on to the next slide. This is how a typical power plant can be installed. These units can be installed indoor or on rooftops or in multi-megawatt configuration.